So our two-way frequency tables, that's how we represent and make sense of our categorical data. So our discrete categories. So for example, the one we just looked at was like pets and gender. We only have a few discrete categories in each, so it made sense to represent it in a table. But this example here is an example of a scatter plot, which you might have looked at in class already. So scatterplots represent bivariate numerical data. So when we have two numerical variables, scatterplots are really awesome. Obviously, they represent this really well. Because again, coming back to my analogy like with a table, can you imagine if I had to have like a column or a row in my table for like 20,000 kilometers, for 35,000 kilometers, for 49,000 kilometers, for 161 and 743,000 kilometers. It just doesn't make any sense. It's not practical to represent this in a table. But that's where scatterplots come in super, super handy for representing bivariate numerical data, because it is ongoing, it's continuous, there's so many different possible variables. But by having this one axis with all of the numbers along it, we can actually plot every point. And every point has a corresponding value for our explanatory variable, which is along our x-axis, and our response variable, which is along our y-axis. So this car, for example, has driven about 265,000 kilometers, and it costs about $9,000 approximately. If I was going to check exactly, I could, but just by having this scatter plot, we can actually read off it and get a lot of information about it. So like I said, another really good thing about scatterplots is they're visual. We can see patterns, we can see trends, and then we can actually observe them and discuss them and see what do they actually mean. A few key things in scatterplots: make sure title is always really important. And again, we're usually talking about correlation in scatterplots. So I've called this correlation between kilometers traveled and price of 2012 Toyota Corollas. And it's just fairly standard form as well, that you put your explanatory variable on the axis down the bottom, and the response variable goes on your vertical axis, your y-axis. So here, kilometers traveled, I thought that was my explanatory variable, because I thought how many kilometers the car has traveled may explain like the change in the price of the car. Definitely not the only factor, but I definitely thought it might be a big factor. So this is how I put together my scatter plot. And you can start to see that we actually do have like a pattern. Patterns are just any overarching trends or any conclusion you can actually draw from your scatter plot. And so that's, a quick introduction to scatter plots. So there are lots and lots of different things we can actually talk about when we're discussing a scatter plot. The first thing we can talk about, is it a positive direction? Is it a negative direction? Or is there no association? All right, I don't know if I have a slide for that, but let's discuss what that means now. So direction, is it positive? Is it negative? Or is there no association? So what I'm seeing here is a overall decreasing direction. That's the trend that I'm seeing. So this scatter plot, I would say, has a negative direction. If it was going to have a positive direction, it would mean it would be moving up. So as one variable increases, the other one would be moving up. But that's actually not what we see here. We actually see that decreasing trend, which is our negative relationship. Of course, the other option is no association. So that's if our points were all kind of just randomly scattered about and there's not really any sense of direction to it. We'd say it has no association, because you can't have a positive or negative direction in that scenario. But here we have a negative direction. So we can see that that's telling me that as the kilometers traveled increases, the price of the car decreases. So that's what our negative relationship is. As one variable increases, the other variable decreases. Whereas in a positive relationship, as one increases, so does the other. And that's how we get that positive relationship. So again, whenever you're discussing a scatter plot, we're thinking direction, form, strength, and outliers. So direction, I've decided it's negative. Form, linear or non-linear. So linear is saying like it's forming like a linear pattern, like a straight line. Whereas non-linear, it could be like going like this, or it could be like changing directions, anything that's not in a straight line. This does appear to me to be a linear pattern because it does look like it's following a straight line for the most part of things. But there's some further statistical analysis, like a residual plot, that tells you a little bit more about that, and we'll get into that soon. So I'm going to say this is linear for now until I can see if it is by testing that out later. Strength, is it weak? Is it moderate? Is it strong? This is looking fairly strong, so I'd probably say like moderate to strong, because if it was weak, the points would be quite spread out. If it was strong, they'd be really close together. So, but there is definitely a fairly strong looking pattern there. So I'd say it's like a moderate to strong relationship. And I don't really see like any obvious outliers. Like, I mean, maybe that one, but not really. It still like generally falls in with our pattern. So if I was going to describe this, like I have on our next slide, I would say the scatter plot revealed, like I did say a moderate to strong. I said it was negative, and I said it was a linear association with no evident outliers. So when you're discussing the relationship between two variables, those are all of the key things that you want to be hitting on.